this PPT is visible to you? This PPT is visible to everyone?
Yes, sir.
Okay, yes, fine. So the next one is we have already done the ADC. Okay, and what the DAC is expected to work is exactly in the opposite way of the ADC. Okay, so I hope you might have studied in your second or third semester in digital electronics, okay, regarding this DAC in detail. Okay, that there are various types of the DAC. So basically what this DAC is expected to do, it is going to take the digital values, okay, and it is going to convert them into analog. Okay, now what this DAC is, these are all the names, like you can find it various books, right? DAC, D oblique A, D2A. Okay, so what it is basically doing, it is going to convert the binary values into set of continuous analog voltages. So what we are going to do with this digital to analog converter, that is DAC, is we will be generating different waveforms. Okay, we'll write the code and you have to generate different waveforms, just like a staircase waveform. We can have the triangular waveform, we can have the square wave waveform, we can have the sinusoidal waveform. Okay, so we can generate various different waveforms by using the DAC. Okay, we have to interface DAC to 8051. Now, basically I have not taken those details over here, but you know that there are two types of DACs. That is, one is weighted register, second one is R2R ladder register. And I hope if you remember that R2R ladder register is the best one, because in the weighted register we are going to take the registers accordingly weighted in the powers of 2 raised to power something, and exactly that valued register is very hard to get. So that may lead to some discrepancies in the output. Okay, so we are making the R2R ladder type DAC, and the precision is the best one into this. So that's why majority of the ICs are employing R2R ladder type. Okay, so you can read it if you want. Like, I have not included here in this discussion. Okay, that is not required. So please remember that this DAC will be applying R2R ladder type. Okay, and definitely it has the op amp for sure, okay, inside it, but we will see this uh, by through the eyes of the IC, okay, that we are going to connect. Okay, so each of the technique that you use, weighted register and R2R, is having own advantage and disadvantage. Okay, so I told you that this weighted register DAC and R2R DAC, this one is mostly preferred because it provides a better precision. Why weighted register is not? Because exactly the same valued register is sometimes not possible to get. Okay, now you know that your computer is a binary machine, okay, or it can only understand zeros and ones. Okay, but our world is analog world. Okay, like if I give you that, okay, fine, I can give you a matrix of 0 1 0 1 0 1, okay, like that. And if I'm telling you this is the matrix of the sine signal, okay, will we be able to understand? Definitely not. The computer may be able to understand that this is the actually that understands this language only, but in our case we will be able to understand only this when we see the waveform like this, that this will be the sine wave. Any other thing, whether it is representing the same thing, we will not be able to understand. Why? Because the external environment in which we live, our world is analog, not digital. Okay, so whatever we actually sense is in the form of analog, it's not in the form of digital. Okay, so if you want to understand the output of the computer, you have to take it on some different type of uh, like you'll have to convert it into the appropriate form, so that it is going to be uh, reflected in the same way, okay, in which we are going to perceive. So there the DAC is coming into picture. Okay. Now let's go into a little bit deep of DAC. So the first thing is going to be its resolution. Okay. So how many bits are there basically? Okay. How many binary inputs it can take? The more binary inputs it can take to produce the output, which is analog, that will be the best one. Okay, so some common one are like 8, 10, 12 bits. Okay, so here we will be having the 8 bits DAC 0808. Okay, so what will be the resolution? Okay, so the resolution of the DAC, because the number of analog output levels is equal to 2 raised to power something, जो भी आपका n है, where n is the number of data input bits. Okay, so this is the resolution. Now with 8.8 input DAC, if you have 2 raised to power n, 2 raised to power 8 हो जाएगा, and that will be 256 discrete levels of output. If you take 12-bit DAC, then it will be 2 raised to power 12. The value will be coming like this. And there are 16-bit DAC as well. So because you can see that the resolution is going to increase, and when your resolution is going to increase, the more precisely it will be able to what I can say is the more number of combinations it can accept. Okay, like if I say you that we have only 2 binary numbers like x and y, so there are only 4 combinations possible. If we have 3 binary number configurations, we have 8 combinations possible. And similarly, when you increase the number of bits, the number of discrete levels that are there, like if I have x, y, z and k, then it becomes 16 different levels. So more precisely you can produce the analog signal. It's just like a maybe when you have simulated any circuit, you are putting input like what will be the resolution. So you fill it like that the first value you are taking at 0. So at an interval of 0.01, you take the values between 0 to 5 range. So it will take around 100 values, like 0 to 1 if I assume, it will take 100 values, and then it will be plotting the curve. If you change the resolution to 0.001, it will take 1000 values. So this curve, which will be plotted by using the 1000 values, will be more accurate, more smoother as compared to the previous. So if more number of data bits the DAC is able to take, the resolution and the output is better. But remember, the expense will also increase. But we have to focus on DAC 0808. Okay, so what this will be doing, this is converting the digital inputs which are there across it into a current. Okay, so please remember the output of DAC 0808 is a current. So you need to convert it into the voltage. Okay, so if I want to convert the current into voltage, it needs to be converted into voltage. So who is going to tell me that how we can convert? Okay, yeah, Krupansh, you are there? Krupansh? Krupansh, are you there? Krupansh, are you there? Krupansh is not yet joined. Okay, fine. Yeah, Utkarsh. Utkarsh. Utkarsh, you are listening to me? उत्कर्ष
हेलो सर मैं हूँ बट सर मेरा वो फोन पे इंटरव्यू चल रहा है सर कंपनी का 1 मिनट सर
ओके ओके
हाँ
ठीक है ओके यश यू टेल मी यश
Yes, sir.
please tell me that if you you have the output which is there in the form of the current. So how you can convert into the appropriate voltage? Can you please tell me the methods through which we can convert it into the voltage?
सर आउटपुट इन करंट है, उसको वोल्टेज में कन्वर्ट करना है.
करेक्ट.
से जो नीचे फॉर्मूला इससे हो गया तो
नहीं, ये तो कुछ और ही है.
ओके, ये नहीं तो फिर तो नहीं,
ये तो आई आउट का फॉर्मूला है. तुम्हें मैं करंट दे रहा हूँ, मैं बोल रहा हूँ इसको वोल्टेज में कन्वर्ट करो. कैसे करोगे?
से V = IR के थ्रू.
हाँ, तो वही तो पूछ रहा हूँ, कैसे क्या करेंगे?
okay, वो नॉर्मल वैसे पूछ रहा हूँ.
Sometimes the questions are very normal.
मुझे लगा कोई और लाइक मेथड का पूछ रहे हो आप. तो एक V = IR ही रहेगा ना फिर.
Yeah, someone is saying something. Please go ahead, beta. Yeah,
Yes, sir.
correct.
Sir, will we use an op-amp?
We can use a op-amp also, right? Current to voltage converter, right? I to V converters are there with op-amp. We will use that also. Can use that also. Actually, we are using that because that is precise. Okay. But we can also attach a resistor and we can see the output to be verified. Okay. So please remember that always the question which is going to be asked is not having the complex answers. Okay. You will face many places where we'll get some questions which are completely out of the way. Okay. Let me tell you a very recent story that was let me tell you a very recent story that that had happened in one of the interviews. Okay, I was actually working as a faculty for the PG diploma people, which who came after graduation for the postgraduate programs run by the CDAC. So I was the faculty coordinator there. Okay, for one of the programs in digital VLSI. Okay, so there one student was there. Her name was Cesar. Okay, and she was appearing for the Xilinx interview. Okay, and Xilinx is a giant. Okay, whatever you are getting the chips and all, Xilinx is actually the giant into the IC technologies. Okay, I hope you have heard the name. And she had to appear for an interview for which she had already cleared the written test, and this was the final interview, right? And that interview was around, the initial package was around more than 15 lakhs. And she was a very good student actually. She was very intelligent as well. And before going for the interview, she came to me, sir, please more point the topics which you think that it will be asked to me in the expected in the Viva. So I don't want to lose this opportunity, this and that. Okay, fine. I helped her. Okay, but I also pointed out that whatever you are doing, beta, that is okay. Okay, but you try to look into the basics as well, because there are chances that you will not be asked any of the questions from the topics because they have already tested the technical concepts. But she was not agreed to my point at that time because she felt that nahi ho sakta hai sir, galat bol raha hu. But I was telling her with my experience. So when she appeared for the interview, the first sentence that those people told her that Miss Cecil, we have already tested your technical ability, so we are quite sure of that you know all the programming skills and everything to be like it's fine with you, not a problem. So we would like to check some basics with you. So the first question that was asked to her was that, tell me what is the time taken by the light to reach from sun to earth? Okay, now you expect this question to think over this question, then when you have studied this concept. Yes, when you have studied this concept, in which class you have studied?
So 7th 8th में.
7th 8th में, उससे भी पहले शायद.
हाँ सर.
ठीक है, क्लास 4 5 में. ओके, और ये क्वेश्चन आपको कहाँ पे अपीयर हो रहा है? When you have done your engineering, when you have done your postgraduate diploma, you have completed it, and then you are sitting for an interview for a very giant infrastructure and very handsome package, and they're asking you this question. Okay, and if you don't know, you are out of the thing. Why? Because the basics are not clear. So don't like, what is the time? Can anyone tell me what is the time taken by the light to reach from sun to earth in this batch without googling it?
So 7 minutes.
7 minutes. Okay. Nobody knows. Yeah, Parth.
Sir, 8 minutes 20 seconds.
8 minutes 20 seconds.
Yes, sir.
Okay. It is the right option that you are giving me. As far as I know, it's 300 seconds. So uh, I think it's 300 seconds is the right answer. Okay, maybe I'm not, like, I don't remember that answer. Maybe you can Google it later on, but I just want to point out that these things will matter. Okay, in your interview, maybe you will be asked that tell me Newton's third law. What you will come to know. Okay, at that point of time, tell me the law of friction. That has nothing to do with whatever you are going to appear for. But the thing is what, that I think I have already discussed in the class also, that nowadays all of you are having 90% in your 10th and 12th. Okay, and all of you will be having more than 85% marks in your PTech. Okay, now you please tell me that on what criteria I should select you. I should segregate the good students and the good candidates and the poor candidates. Definitely not on the basis of marks. Okay, so please always brush up the things that you have studied. Whether you have studied it in class 3 or 4, that doesn't matter. At what point of time you are going to be asked at which question, nobody knows. Okay, fine. एंड डेफिनेटली इंजीनियरिंग वाला तो आपका इंपॉर्टेंट है ही, वो तो श्योर है, ठीक है, कि वो आपसे पूछा ही जाएगा. बट टू चेक योर लाइक mental ability, that how much you can recall or how much sincere you were, how much what is the do you have that data in your mind which you have studied long back. So checking all these abilities will take such kind of very simple question. Okay, fine. I hope you are getting my point. I'm not deviating from the subject. Fine. So please, what I mean to say by this is, you whatever you are studying, please study it appropriately. Please try to put some data in your mind, and that data should not be going out of your mind. Okay, I'm not telling you to memorize some very complex formulas, and nobody is going to ask you that actually, but they must ask you that. Okay, fine. Tell me this quantity is dependent on how many terms. Okay, so such kind of analysis is always asked. Okay, now come to the subject. Fine, I hope you have got this point. So the output is current, and you can convert it into the voltage by using a normal resistor or by using the op-amp. Now you know that the op-amp is the best one. Okay, you have studied it a lot in your LICS subject, all great detail. I don't want to ask you the question from that. Okay, because it will waste more and more time. And okay, fine. One more thing I forgot to ask. We can extend it a little bit. Now you don't have the successive lectures. Anyone? At least half an hour. If any lecture is planned.
No, sir.
Okay, fine. Okay, so how this output is actually dependent on. So I told you that this is the output that is that this DAC is providing. So this is the formula for the calculation. So there will be the I reference, and these are the bits which are provided at the input. So what is the input is there? Like you can say that basically your DAC will be the what? These are the digital inputs, and it will be producing the output which is in the form of current, obviously. Okay, or I will say that it's an analog output. That is what this DAC is going to perform. So depending on these bits, they will be calculated. So simply you can see that this is 2 raised to power 0, 2 raised to power 2, 2 raised to power 3, and so on. This will be 2 raised to power 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 bits, and this is the way to calculate. This is the MSB. This is the LSB of the data. Okay, and generally we keep this reference current to be constant, and it is known to you that the reference current is 2 milliamperes. Okay, and some standard power supplies are also used into this, so you can see this one. Okay, so here is the connection for this. So this is the 8051. What you have to do, that's going to be very simple program. Okay, all that you need to do, but I will not tell you the simple one. That I'm going to give you one simple one and one complex one as your homework for the experiment that you have to perform. One complex one I will tell you, one logic I will tell you, but the rest of the things you have to show me in the next lab. So next lab I'm not going to tell you anything. Next is your presentation with what you have done. Okay, so now just look at it. This is my 8051 microcontroller. So we are giving the input via port 1. That is optional. Any of the port you can take. Here in this figure we are taking it to port 1, and these are the data inputs which are given over here. So these are the inputs of DAC, and you can see that this is the output that you have, and this is I to V converter. Okay, via op-amp. Okay, and these are the rest of the inputs that you have to provide inside. Okay, so obviously those are VCC, reference plus, reference minus, compensation, V, ground. So you know all these things are present into the op-amp. So some are for op-amp, some are for this circuit. Read and write pins are not there. Okay, in your chip that we are going to use. Okay, so this is the interfacing diagram. And one more thing I have observed, that people who have written the exam without their interfacing program, उनका मार्क मैंने 1 मार्क ही कट किया है अभी 4 मार्क में से. याद रखिएगा, अगर आपने इंटरफेसिंग डायग्राम नहीं बना के कोड लिखा तो नेक्स्ट टाइम से मैं 50% मार्क कट कर लूंगा. ठीक है, बिकॉज इंटरफेसिंग डायग्राम के बिना आप कोड लिख ही नहीं सकते हो. There are so many people who have done this mistake, despite of I had already told you this thing, that please don't do this thing. First you make the interfacing diagram, then you write the program. इंटरफेसिंग डायग्राम से आपको कम से कम 30% मार्क तो तुरंत मिल जाएगा, even if your code is wrong. Please mark this point, everyone. I have seen in the many papers. So I think people who are scoring 7 marks and they have written the program are falling in this category. Okay. So accordingly, if I use this concept, okay, and if I use this formula, so there are 2 examples. Like if I give it the input of 99H and C8H, then what will be the voltage at the output? So here at the output I am simply using R is equal to 5K, that is the normal resistor I will apply. So how I am going to apply? So I'll simply multiply the current by the resistance. So V is equals to IR concept. So how we are going to calculate the I out? Okay, this is the formula for I out. What is that? Reference current into this value. So accordingly, what you have to do? You have to put the values at these digits, whatever you have. So you just look into 99H. This you have to put in the formula. This becomes D7. This becomes D0. Right? So you put it in this formula, calculate it, you'll get this value. Okay. So this is the output current that you will be getting, and this output current will be producing this much output voltage. Why? Because you are going to multiply by 5K. Okay. Now similarly, if you take any other value like C8H, so put it in the formula again, you'll get this current and the voltage will be this. So what you can observe here is, this is the output of this 99H and this is the output of C8H. So what you can observe from here is, just by changing the bits at the input, you can change the output voltage. Fine. Now if all are 1111, then what will be the value? You can verify. Okay, it will be 1.99 milliamperes. Okay, the maximum output current will be 1.99 milliamperes. Okay, you can verify by yourself. Anyways, now come to the point. So have you got this point, everyone, that how the output current is provided on which formula in your DAC 0808? You have come to know about this. Please remember, this formula is very important. Please remember, that MSB is divided by 2, not the NSB. Okay, I have seen many people doing wrong over here. You write everything, but here you make the mistake. Here you take D0, D1, or you are starting from this side. So please make sure that D7 gets divided by 2, and then you are going to increase the things. Any question till this point? Any question from your side?
No, sir.
Okay. As I told you, this is very simple one, but this is very important one, right? You have to think, or while writing the program, you'll have to think a lot how we have to select. The program will be simple but logical. So how you can do that? As I have already discussed this, that how you can convert IO to the voltage. So you can connect a resistor, okay, to convert this voltage, and you can monitor the output in the scope. But it leads to some inaccuracy that you know already. Just a second, I have an important call. Okay. Yeah, I'm sorry. Some urgent work has come from the college, so that's why I had to attend. Okay. So what I was telling you that yes, we can attach the register. I hope I'm audible. Hello.
Yes, sir.
Okay, fine. So because some inaccuracy can be observed when you connect the load resistance, okay, and that is also sometimes that is also affecting the performance of the circuit that you are connecting over there due to the impedance mismatching purpose and so many things. Okay, so that's why it's always better to connect IC741, that is op amp. Okay, uh, by in like it will be used as I to V converter. Okay, and that we will see in our interfacing diagram as well. So there are two ways. One way is by connecting op amp, another way is connecting a simple register. So these are the input diagrams. They are, that is not that much complex. If you see that there are so many inputs, okay, these are all inputs. Okay, these are all inputs, and then this is VCC, reference voltages, compensation if you need, then here voltage and ground. Okay, and fourth one is the output that you are getting from here. Okay, the output current. Okay, so that's very simple. There is nothing in this pen diagram that much. Now you have to do is, first program that we are going to do is the generating the staircase waveform using DAC 0808. Okay, so please remember that here you don't have to put that much effort in, for generating the program, the waveform. Okay, it's going to be simple, but you have to think of it, that how you are going to pass the data. Okay, so let me explain how I am generating the staircase waveform. So here the question will be coming in your exam as well, that write a program to generate a sine wave or triangular wave or staircase wave or square wave by using 0808. And remember, don't forget to mention the interfacing diagram. That is 100% required. Okay. So now you just look at it that here the staircase waveform I want to see how we are going to do that. Okay. So first, how we are going to take the staircase waveform is it's very simple analogy I'm telling you. Like we have our accumulator, okay, and what I have taken in this program is a very simple approach. First, I have initiated with 0, 0, 0, 0. Then I'm going to OR this by 1. Okay, so when you OR this accumulator by using which command ORLA with which data 01H, so it will be ORed. Right? So you can see that now this data is going to be this one. Okay, so according to this is the first value for which the output will be coming. You know that how the voltage will be coming. It will be depending on various factors, that what is your reference current, and depending on that it will be generating the output. So some output will be coming for this value. The second output will be coming for this value. Okay, this will be converted. I will be transferring it to port 1. Then simply I will rotate it. Like what will be the third thing is, like it will be 1, 0. This will be the third number. And similarly, you have to rotate. Now the 1 will come over here and all zeros. Okay. Now the 1 will come over here with all zeros. Fine. So this is the way in which we will be doing the things. Okay. So if you see this one, okay, in the accumulator, okay, if you see this one in the code, so this is the program that I explained. This is the heart of the thing for which we are writing the things. So just look at it now. First, I have taken, you are starting it from 030H. Okay, that's normally taken when you are interfacing certain thing. Anyways, you can avoid this line also. So how we are going to start? We are going to start with move a hash 00H, and we are moving it to port 1, and then we are calling the delay. And here I have written the delay subroutine. Okay, so I hope that there is no you don't have to you will not feel any problem in understanding this. This is by using your timer registers. You can very easily generate the delay, and this will produce certain amount of delay that you can calculate and then you can write it. Okay. If you are being told that the delay should be equal to this much, then you have to calculate at some moment itself, at that moment itself. But such complex questions, the problem will be actually too much complex. So, and we cannot provide higher mark than 8. So I won't put this in that question that you have to calculate it for the delay as well. So I have selected a value. So what we are going to do is we are going to do move P1A call delay. Okay. And then you are going to rotate left the accumulator. Okay. So this will what this will be doing? This will be rotating left the accumulator. Okay. And whenever until unless your A becomes 0, okay, that will not be so. So if you see, if you are going to rotate the accumulator, it will never be like, it will never become 0 now, because this will be rotated. So continuously your wave will be produced. Okay, the staircase waveform will be produced. Okay, because see, if you have put this one over here, and when you are rotating it by left, so you can see that if you rotate left, the last one will be that this one will come over here. So it will never become 0, 0, and that you also don't want. Why? Because you need that curve to be running continuously. Okay. So this is the loop, or this is forming the loop. You can see first what we are going to do. We are going to take 0, 0 in A, then we are moving it to port 1. Then we are calling the delay, then we are going to OR it with a number. And then we are, after doing the OR, we are going to put it in the, where we are going to put it in the port 1, and then we are calling the delay. And then we are rotating it left. Okay, and if accumulator is not 0, definitely not 0, then you are again doing it continuously. You are moving it. You can see, go to the next. Okay, and then when you go to the next, you have to go to this again. So this will be executed infinitely, you can say, and infinitely you will get your, or you can say you can get a continuous waveform at the output. So the code is very simple. Okay, but you have to think over it, that how we are going to implement. There can be other ways to implement it as well. Maybe you will be, when you are studying in the book in Masidi and all, they have done it in some other ways. Okay, but I have done it my way, how I can do that. This is also a way to do that. You can do this in some other ways also. There is no problem with that. But this is also a very simple way to do this. Okay. Now here, the waveform will be coming like this. Okay, and the step size will be different. How many of you understand this thing, that when you execute this code, the step size will be different? How many of you understand this thing? Please tell me. Do you understand this thing? Yes, everyone? Or shall I ask? Okay, Rafa.
Yes, sir. Yes,
Yeah,
sir.
please tell me that. Am I right over here that the step size will be different?
Sir, I'm not sure. Maybe because you're rotating it at you're rotating it and
Obviously,
it's not
obviously.
increasing at the same with each
Yeah,
value being the
obviously.
same.
See, if the first output will be coming for this, second output will be coming for this, third output will be coming for this. Okay, and these are not same. Okay, when you put it in the formula, the I out will not be same, or the increment will not be same if you are switching from here to here and here to here. Okay, but with this concept, you can you cannot generate that the equal waveform. For that you have to take some other means, or in other way you have to code it. Okay, but yes, this will generate the staircase, but not with the equal steps. Okay, because you are rotating. When you rotate the things, the difference between two successive numbers for which the output is going to be generated will not be the same. Okay, what is the first output? These are all 0. Then first output is generated for 0 0 0 0. Second output is generated for 0 0 0 1. Third output is generated for 0 0 1 0. Fourth output is generated for 0 1 0 0. Fifth output is generated for 1 0 0 0. These are all zeros. So you just understand this, that the difference between the values of two successive values are not same.
सर ये एक्सपोनेंशियली बढ़ते जा रहे हैं, तो लाइक ना आगे के जो स्टेप्स है कि वो डबल इंक्रीज के हिसाब से रहेगी, क्योंकि 2 की पावर पे जा रहा है ना.
You cannot say exactly double होगा, ठीक है, but
सर लाइक एक्सपोनेंशियली जाएगा.
एक्सपोनेंशियली जाएगा, ऑब्वियसली वो एक्सपोनेंशियली जाएगा, तो वो और बड़ा होगा, मतलब आगे का जो स्टेप है वो बढ़ता चला जाएगा. बट यस, इट्स अ स्टेयरकेस वेवफॉर्म, दैट इज फॉर श्योर. ओके, दैट वी कैन वेरीफाई फ्रॉम आवर आउटपुट एज वेल. Shall I show you the output?
Yes,
ये कोड
sir.
समझने में किसी को कोई तकलीफ? See, the same thing you can, like if you have the same step size, then you have to code it in a different way. You did not to be incorporating the rotate in that case. You can select some values and you can pass it to the program. There is no problem into that. Okay.
So why can't we simply just increment by 1?
You can do that as well. Not a problem. Okay, you can do that as
so
well.
So it will result in
But
equivalent step sizes.
This is what I'm telling you, that you can, for that you have to incorporate some other technique. You can do that increment.
Okay.
You can do that. You can directly take some values and you can take them in data pointer and you can point to those values.
Yes.
Are you getting it? But with this approach, you will not get the same step. You will get different steps. But yes, this is a staircase waveform. Okay. Any problem in this one?
No, sir.
Okay, fine. So in that case, let's look at the output that we have. This is the program. And so this is the same program. I hope that I should not be showing it to you now, that you can do it. Okay, let me show you the Proteus diagram for it. Okay, let me show you the Proteus diagram first of all, then let me show you the output. Then you can see the connection. This is not required, so I will remove this. Okay, put the appropriate hex file. Okay, save it and run it. Yeah, now look at the waveform. Can you see the staircase waveform, everyone? Okay, initially the steps are going to be small and later on it's going to increase. If you want to see this clearly, you can. Can you see the waveform, everyone?
Yes,
and this
sir.
is Going on.
Sir, but why is it reaching 0?
Which one?
Sir, like why is it coming back to 0? I thought it's going to infinitely keep on increasing.
But it will how it will not exceed like what is that value is. You can it is going to be like it is exactly not returning at 0 value, but it is returning at the minimum value. Which one is that? 0 0 0 0 0 0 0 1. Because when you keep on rotating, after 1 triple 0 and 4 times 0, it will that 1 will go to the LSB. So what is the value is 0 0 0 0 0 0 0 1. Are you getting that
Yes,
point?
sir.
So for that,
Yes,
it
sir.
again
Yeah.
return to the, it's not going to be zero, but it is returning to the minimum level. Why? Because when you rotate it left accumulator, okay, that one will be rotated from LSB to MSB, and then MSB will come to the LSB, and that is the point when it is coming to this point. You can see this one over here. Okay, and you can see this. I hope that this is visible to you. ओके सो अभी देखिए यहाँ पे आपका ये जो वेव फॉर्म है कैसा दिख रहा है छोटे छोटे स्टेप्स में बढ़ रहा है आई टोल्ड यू द स्टेप साइज विल नॉट बी द सेम सो डिफरेंट स्टेप साइज बट इट्स अ स्टेयरकेस वेव फॉर्म ओके everyone is able to understand this one if you have any doubt so what I will be giving you is the task of generating different types of waveforms okay so any question see it is infinitely producing the signal because see, you know that the accumulator will never become 0 0 0 0 now ठीक है इसको समझने में किसी को कोई तकलीफ दिख रहा स्टेयरकेस वेवफॉर्म आपको या प्लीज रिस्पॉन्ड
Yes, sir.
okay so it's your turn now let's start doing the practical in that case what I can do from my side for doing it quickly is I can share the word the file with you okay which file that program ka file so that you can do it a little bit faster because it will take a little bit of time you can see that all the connections are done over here in the same manner okay जो हमने यहाँ पे प्रपोज किया था आप देखिए यहाँ पे कैसे कनेक्शन किया है ये है आपका 8051 अभी देखो यहाँ पे कृपांश आर यू देयर
Yes.
okay Krupansh just look at it we have connected the external from crystal from outside so there is no crystal available inside you have to connect it from outside with the appropriate value so that it is going to produce the clock signals for it okay
Yes.
and this is a DAC 0808 okay so accordingly we will do the connection okay so now please start doing this thing now we have connected at the output we have connected a op-amp also okay as a I to V converter and finally the output we are looking at a digital oscilloscope fine can you do this thing
Yes, sir.
so I'll share that file with you I can share that cold file I'm going to share the ASM file with you so so that you can make it so let me share the ASM file with you चलिए ओपन करिए फिर फटाफट से ओपन योर की okay what I'll do I'll put it in the group चैट बॉक्स थोड़ा लेट से ओपन होता है इसमें, so I'll put it in the file section of microcontroller. I'm simply going to upload it. Okay, it's already uploaded. You can see dac.asm already uploaded. You can take it from there. You don't have to write the code. So code is very simple. Have you got the file? Started working? Open your keel. You can take my ASM file. You can attach it. You can keep it over there, or you can copy paste it from there. Or if you wish, I can send you that it in Notepad also. See, I have sent you the text file as well. You can take it from here also, and you can start working. वहाँ पे मैंने ASM फाइल भी अपलोड किया है. If you want to take it from there. Have you started working everyone? आज मैं किसी का भी स्क्रीन बोलूँगा शेयर करने और उसका स्क्रीन देखूंगा, ठीक है? तो टाइम पास कोई भी नहीं करेगा, मुझे आउटपुट चाहिए. तो मैं किसी को भी बोल सकता हूँ कि अपना स्क्रीन शेयर करो. So you have to do it genuinely. Have you received the file? You can take it from the file section also. I'll put it over there also. See, dsc.txt is there. You can download it from here. या तो ASM फाइल या ये कोई भी. Fine. Okay. I hope everyone has started doing the work. सबको मिल गया फाइल मिल गया सबको?
Yes, sir.
Yes, sir.
Right. Now you please start first to generate the hex file.
So can you show the
Sir, could
connection?
you show the schematic diagram in Proteus, please?
Yeah, Proteus, I'm showing you. It's already there. Like, first to generate the hex file by using this, then you can.
Sir, it's already done.
Okay. So people who are done, let me show you this thing. I hope it is visible. Visible to all of you? And I hope that you don't need my guidance now to how to take the components and how to do the things. Okay, if you are not able to recall, you can tell me. I'll tell you how I have selected. I will show anyone today to share the screen with me, and then only I'll mark your attendance. Done with the thing? Are you getting the output? Yeah, getting the output, everyone? Tell me. Or making the connections?
Still making, sir.
You're making the connection.
Okay. Yeah, take your time. Okay.
So normally you have to take the value of VCC and VE.
Pardon?
How much do you have to take the value of VCC and VEE?
Yeah, these values. Okay, let me show you. This we have taken to normal supplies that we have generally we have been generally connected to the op-amp. Plus minus 12 volt I have connected for this VCC. It's, look at this for this VCC. This VE is minus 12 and this VCC is plus 12. Okay, here we have simply connected the power. Okay, and anything here we have connected, I think 50, minus 12.
So what's the value of C1 and C2?
C1 and C2 are 33 picofarads. Crystal you have to connect is a 12 megahertz crystal. It will work for 11.0592 as well. You can connect 12. That works.
Done, sir.
Done. You're getting the output.
Yes, sir.
Today I'll ask anyone to show his screen. You have to complete it definitely.
So what's the value of VCC?
VCC is plus 12.
Okay.
V is minus 12. Here also it is minus 12.
So which op-amp do we require?
IC 741. Go to P and type 741.
Okay, sir.
So how do we get a component with those pulses?
This one?
No, so that
Which one
box,
you?
the ABC. The one which is connected to resistor 4. Yeah, so this pattern.
This one.
Yeah.
These are the normal registers. So type RES. Go to P. Type RES.
No. So I want that box, the one that you were talking about.
This one you are okay. Right. Okay. Here you have to go to the component mode. Then you will get this box. This box you are telling.
Yes, sir.
Click on the component. Then you'll get this box. Then go to P, and then you can write RES. You can select this, and then click on OK. So
No,
if this
not the
window is like if you
resistor.
can
Not the
for the
resistor.
resistor,
I got the resistor.
then which one you
The
are not
box.
getting? Tell me. This
So
one.
the box with with those
So
terminals
she's
A,
talking
B,
about
C, D.
oscilloscope.
Oscilloscope you are talking about. This one.
Oh, that's an oscilloscope. I couldn't figure out what it is.
You can take it from here also. You can see it is directly over here. You can go to this point. Just below this. Instruments. Okay. Go to instruments from here, and you can take this oscilloscope from here. Directly you can take the components from here also, not a problem.
Okay, thank you.
So
यस
vref कैसे लेना है? राइट क्लिक करके प्लेस किया, फिर
कहाँ पे है vref? यू आर टॉकिंग अबाउट दिस VCCV ये सब?
सर ये C1 है ना जो कैपेसिटर 3 के ऊपर है,
ये
VCC
वाला ना?
वाला, हाँ VCCV
क्या
के लिए
करना
जो
है?
यूज किया।
राइट क्लिक करो, गो टू द जनरेटर एंड देयर यू गो टू DC. प्लेस करेंगे, डबल क्लिक करेंगे, जो भी आपको नाम देना है दीजिए, वोल्टेज जितना देना है प्लस माइनस 12 जो भी दीजिए, एंड देन यू कनेक्ट इट. This 12 volt actually. If you want to change the name, you can.
सर VCC, VEE और C31 सब में 12 वोल्ट देना ना?
सब में यहाँ पे -12 है, ये VE और कंपनसेशन में -12 वोल्ट है. ये ओपैम्प को एक प्लस और एक नेगेटिव सप्लाई लगता है. पिन नंबर 7 पे पॉजिटिव, पिन नंबर 4 पे नेगेटिव, तो हमने यहाँ पे +12 और -12 दिया है. ठीक है, ये VCC है, ये VE है. आई हैव केप्ट द नोटेशंस टू बी simple only that we have already used in the previous semesters.
सर एक बार ऑसिलोस्कोप वापस बताओ ना, आपकी स्क्रीन मतलब लैग हो रही है, जो डिस्प्ले हो रहा है, तो उसके लिए उस टाइम पे दिखा नहीं था. एक बार बोल दो तो मैं वैसे कर लेता हूँ.
वहाँ पे भी जाके देखो, राइट क्लिक करो, प्लेस में जाओ और वर्चुअल इंस्ट्रूमेंट में जाओ.
ओके.
यहाँ पे अभी दिख रहा है स्क्रीन पे?
हाँ सर, मैं नहीं सर, आपकी स्क्रीन अभी तक पुराने उसमें ही हुई है. अब आया वर्चुअल इंस्ट्रूमेंट और ऑसिलोस्कोप देखा आपकी स्क्रीन पे. क्रिस्टल फ्रीक्वेंसी भी 11.0592 करनी है कि 12 रखनी है?
12 भी कर सकते हैं, कोई दिक्कत नहीं. प्रिसाइजली करना है तो 11.0592.
तो ऑसिलोस्कोप में कुछ सेटिंग करनी है?
नहीं, खुद की सेटिंग नहीं करनी.
ओके.
Okay, rest of you please continue. I'll be there in just 1 minute.
पार्थ।
ओके डन।
सर एरर आ रहा है।
क्या एरर आ रहा है?
सर ये बोल रहे हैं नो मॉडल स्पेसिफाइड फॉर U2 DAC के लिए।
नो मॉडल स्पेसिफाइड।
यस सर।
तुमने ये सेम ही लिया ना डीएसी, वहां पे 2-3 ऑप्शंस है एक्चुअली।
सर 0808।
हाँ 0808 में भी।
ओके 0808 में भी मॉडल है क्या एक्स्ट्रा?
यहाँ पे देखो, तुम्हें एनालॉग वाला लेना था, ठीक है ना? ये देखो ध्यान से, तुमने एनालॉग वाला लिया है, ये लिया है। अगर NAT DAC ये वाला लिया होगा ना तो फिर वो सिमुलेट नहीं होता शायद, तो एनालॉग वाला लेना है। चेक करो एक बार कौन सा लिया है।
हाँ सर शायद तक गलत ले लिया।
कोई बात नहीं है, उसको सिर्फ वहां से डिलीट कर दो और फिर वहीं पे पेस्ट करो।
सर सर मेरा सिमुलेशन जब रन कर रहा हूँ मुझे वैल्यूज नहीं दिख रही, मतलब ऑसिलोस्कोप के ग्राफ्स ही नहीं दिख रहे।
तुमने पहली बार रन किया, एक बार पहले भी कर चुके हो?
नहीं, पहली बार रन किया सर।
ओके फाइन। वो चेक करने के लिए कि यहाँ पे कोई आउटपुट आ रहा है कि नहीं, एक काम करो, यहाँ पे एक वोल्ट मीटर वगैरह डालो इधर कुछ।
कहाँ पे सर?
ये देखो यहाँ पे वर्चुअल इंस्ट्रूमेंट में जाके एक
सर आपका सिग्नल जनरेटर।
एक डीसी वोल्ट मीटर सेलेक्ट करके और इसके साथ अटैच करो यहाँ पे ऐसा, तो पता चलेगा कि ये सिग्नल जनरेट भी कर रहा है नहीं कर रहा है। अगर सिग्नल जनरेट कर रहा है दैट मीन्स इसको वेवफॉर्म शो करना चाहिए, ठीक है? जैसे देखो मैं यहाँ पे रन कर रहा हूँ तो देखो यहाँ पे मुझे सिग्नल आ रहा है, 5 वोल्ट तक जा रहा है, फिर नीचे, तो आई कैन सी द वेवफॉर्म। फिर भी अच्छा पहले ये करके देखो।
ओके सर, कर दो, एक मिनट।
ठीक है।
So I'm having the same issue. I did what you said, like attaching a DC voltmeter, and when I ran the program, it's showing -45 as a reading, but I can't see any graphs.
-45?
Yeah, that's what it's showing.
No, then there is something wrong. Please check the connections, because if you see, if I am running the, it will never exceed 5 volts, maximum 5, that's it.
So I'm getting 9.97.
Fixed voltage, it is not varying.
Hello.
Is it varying over there? Just look, you look at my screen.
9.9.
The voltage is varying. It's not stable. It's varying.
यस सर, मेरे भी वही कर रहा है। वो ग्राफ वाली प्रॉब्लम मेरी भी आ रही थी, तो मैंने ऐसे किया तो मेरी भी वही कर रहा है, 0 to 5 के बीच में।
अभी otherwise one more option is there. You go to debug and reset debug pop-up windows. Reset debug pop-up windows. If you are running and you are not getting the output window, तो एक बार debug में जाके reset debug, ये वाला reset debug pop-up windows ये करेंगे ना, फिर जब इसको रन करेंगे तो ये यहाँ से निकल के आएगा।
यस सर, आ गया।
ठीक है, और किसका नहीं आया देखिए।
So the oscilloscope is open, but it is not showing the graph.
So are you getting any voltage that you attach a voltmeter over there and check it?
Yes,
that whether
sir.
you are getting any voltage over there or not?
Yeah, sir, voltage is
तो मेरा
there.
ग्राफ थोड़ा अजीब आ रहा है।
क्या अजीब आ रहा है?
तो स्टेप्स दिख रहे हैं बट बहुत ज्यादा छोटे आ रहे हैं, मतलब लाइक पहले बड़ा
तो
वाला
वही-
स्टेप है, बाद में स्मॉल होते जा रहे हैं।
हाँ, तो ये कनेक्शन उल्टा किया है क्या? यहाँ पे देखो, A8 को मैंने पिन 1.0 से कनेक्ट
ओके,
किया है।
हाँ
अगर
हाँ
ये
सर।
उल्टा किया होगा तो उल्टा आएगा।
हाँ सर।
ठीक है, ये आप चेंज कर सकते हो। अगर आपको ऐसा करना है तो इसमें राइट क्लिक करो कंपोनेंट में और एक्स मिरर कर दो या वाई मिरर कर दो, तो वो शफल होते हैं, ऑप्शन करके देख लो किसमें वो सेट हो रहा है।
हाँ सर।
सर मुझे ग्राफ में अभी स्ट्रेट लाइंस आ रहे हैं, मैंने डिबग किया तो ऑसिलोस्कोप का ग्राफ जनरेट हुआ, बट इट्स शोइंग स्ट्रेट लाइंस।
इट्स कंप्लीट स्ट्रेट लाइन
या सर,
विथ नो डेरिवेशन, नो डेविएशन।
नो डिविएशन सर।
Same, sir.
तुमने यहाँ पे हेक्स फाइल लोड किया है अपना, हेक्स फाइल जनरेट किया है क्या?
हाँ सब जनरेट किया, बोर्न भी किया सर।
और हेक्स फाइल जनरेट करने से पहले तुमने वहाँ पे
Frequency,
कील में उसको कील में लिंक किया था?
हाँ सर किया था।
वो एक बार चेक करो सबसे पहले, क्योंकि क्या वो अगर मिस्टेक होता है तो फिर इधर स्ट्रेट लाइन बताएगा।
सर वो भी चेक किया मैंने, सेम ही आ
ठीक
रहा
है,
है।
ओके, ठीक है, एक काम करो, अपना स्क्रीन शेयर करो, देखें। नहीं तो
Sorry.
एक बार थोड़ा ये कंपोनेंट से देख के मैच करो, कहीं पे कुछ कंपोनेंट का
मैंने
वैल्यू देना पड़ती है।
कंपोनेंट्स के वैल्यूज और डायग्राम दोनों चेक किया, अप्रोक्सीमेटली तो सही लगा। सो आई विल रिक्वेस्ट कंट्रोल फॉर शेयरिंग।
हाँ, ओके। ओ, ये मेरा स्क्रीन है, तुम्हारा स्क्रीन है?
फिर ये आपको बंद करना पड़ेगा।
रुशियल ना?
या सर। So I just saying only meeting organizers and presenters can share.
Making it the present. Now you can share your screen.
So can you see? Hello. Hello. So your mic is muted.
Sorry. So please close this file. Then I can see.
Can you see
Let
this?
me. I can see your screen, but you just close this oscilloscope wala window so
Yes,
that I can see the. Yeah, I can see the circuit. A little bit you have to zoom it.
सर अगर ऑसिलोस्कोप नहीं खुल रहा है तो?
ऑसिलोस्कोप नहीं खुल रहा है तो यहाँ पे जाओ, डीबग में जाओ और वहाँ पे नीचे आएगा रीसेट ऑल। ओके, प्लीज गिव मी द कंट्रोल, अप्रूव इट। Rushil, approve it.
Yes,
I have asked for the control.
Yes, I approved it.
Okay, so
सर हो गया।
So I think his VCC is not connected to the op amp. So
yes, just look at it over here.
is not. I'll change that. So.
Yeah, do it.
Should I try running now?
Save it first of all. Save it and then run it.
So first I'll have to use the debug thing, right, to see the oscilloscope.
Yes. You go to debug. Reset debug pop-up windows. Yes. Now you run things.
So it's still flat.
Wait.
सर VCC में वैल्यू वगैरह दिए क्या?
नहीं है, तो अभी भी कुछ प्रॉब्लम है. क्लोज करो.
Sir, I'm facing the same problem.
Okay.
VCC तो connected है, values भी दिए सर.
क्रिस्टल फ्रीक्वेंसी डाली है?
हाँ सर.
ओके. नहीं, स्क्रीन थोड़ा सा जूम करो.
कील की क्रिस्टल फ्रीक्वेंसी और यहाँ की मैच नहीं होगी तो फिर नहीं चलेगा क्या?
12 मेगाहर्ट्ज इट इज एक्सेप्टिंग. एक्चुअली ये नहीं भी कनेक्ट करोगे तो भी चलेगा, ऐसा कुछ नहीं है. $10.51 nanofarad R2 5K कंपनसेशन दिया है.
So the C4 is 0.1 microfarad, right?
C4, I cannot see my screen now, so I cannot. Okay. Let me.
C4 is
कुछ तो values
So 0.1 microfarad से C4.
C3 C4. Okay. 0.1 microfarad. देखो. क्योंकि कुछ तो मुझे वेरिएशन दिख रहा था. अभी करो यहाँ पे देखो. 0.1 UF.
Yes sir, वो किया मैंने.
Okay.
So I don't think it'll give such a big difference.
नहीं कुछ तो, या तो फिर तुम्हारा सिमुलेशन उधर ही कुछ प्रॉब्लम है. लेट मी चेक. एक बार इसको वापस से रन करके देखो.
सर किया ना रन.
I'm also facing the same
इसका
problem.
वैल्यू भी सर कांस्टेंट देखो ना, 9.97 ही आ रहा है, चेंज ही नहीं हुआ.
हेलो.
Yes sir.
Yes. Just a second. Guys. Yeah, tell me. Who is this? हाँ बोलिए ना. हाँ. Yeah. So show me your that file, right? Keel file.
सर अगर कंप्लीट हो गया तो जा सकते हैं.
हाँ, if you have got the output, you can.
Yes sir. Thank you sir.
file. हाँ, तुमने यहाँ पे .asm करके सेव नहीं किया है ना?
सर किया था एक मिनट. I'll try again.
हाँ एक बार फिर से करो, क्योंकि ये मुझे कलर वो नहीं दिख रहा है।
सर हेक्स फाइल सेव नहीं होती उसमें, ये सोर्स A.5 में, यहाँ पे सिर्फ ASM फाइल रहती है।
हाँ
हेक्स
पर
फाइल बैकग्राउंड में जनरेट होती है।
नहीं नहीं, हेक्स फाइल की मैं बात नहीं कर रहा हूँ। इसने ये जो एक्सपेरिमेंट 5 लिखा है वो .asm से सेव किया है, क्या इसका कलर क्यों नहीं चेंज हुआ?
so now it changed. I'll try boiling it again.
करो ना करो ना करो ना। ये देखो अभी कलर चेंज हुआ। अभी जनरेट करो हेक्स फाइल।
So वापस से hex file generate करो।
हाँ 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 डेफिनेटली।
सर पहले ऐड करना पड़ेगा ना सोर्स ग्रुप में।
वही उसको ऐड करो। ये कहाँ चले गए? ओपन योर कील। ओपन
हाँ
योर
सर
कील एंड यू। हाँ हाँ इसको यहाँ पे ऐड करो और वो फाइल वहां से डिलीट कर दो जो पहले वाली थी। हेक्स फाइल कैसे तुमने अटैच किया है? दैट्स कुछ तो गलत हुआ है तुम्हारा।
हेलो।
हाँ यहाँ पे अटैच करो अभी वो .asm फाइल जो तुमने exp5.asm। नहीं वहाँ नहीं, वहाँ नहीं,
so पहले
वहाँ
hex
नहीं
file
उसके।
generate करना पड़ेगा ना, डिलीट किया तो।
नहीं नहीं नहीं, पहले आपको इसको .asm फाइल को, हेक्स फाइल को ऐड नहीं करते बेटा। सोर्स ग्रुप पे राइट क्लिक करो, सोर्स ग्रुप 1 पे राइट क्लिक करो।
add to
इधर
existing।
इधर सोर्स ग्रुप 1 पे लेफ्ट में
हाँ सर वही किया।
राइट क्लिक, ऐड एग्जिस्टिंग फाइल। हाँ ठीक है, यहाँ पे सर्च करो extend5.asm नॉट हेक्स।
should I add this?
या यू ऐड दैट वन, ऐड। अभी
so
यहाँ
now
पे, हाँ अभी यहाँ पे ये क्लिक करो, बिल्ड करो ऑल फाइल्स, रीबिल्ड ऑल फाइल्स।
so zero error।
हाँ हेक्स फाइल जनरेट हुआ,
हाँ
जीरो
सर।
एरर आया। चलो अभी अभी वापस से इंपोर्ट करो वहाँ पे। हाँ वापस से ये फाइल डालो उधर। यही है जो जनरेट हुआ था। एक सेकंड एक सेकंड एक सेकंड एक सेकंड एक सेकंड, ओपन करो।
so क्या ओपन करूँ?
नहीं नहीं, ये वही हेक्स फाइल है या पहले वाला है, ये मुझे देखना
नहीं
है।
सर
वो
नहीं
राइट,
बात।
वो टाइम से पता चलेगा कभी का हेक्स फाइल है। देखो अभी अभी जनरेट हुआ, इसका टाइम देखो क्या है।
1652
हाँ
सर।
ठीक है ठीक है ठीक है।
मैंने
ओपन
पुरानी वाली
ओपन,
डिलीट कर दी सर।
ठीक है ठीक है फाइन। अभी अभी रन करो वापस।
yes sir now I got it।
So people who are not getting the output, please look into that whether you have done the proper process at keel. That is first of all required. Fine. First you need to generate the proper hex file, only then this circuit is going to work, right? Now still who is not getting the output?
so I can leave now?
Sir, I'm not getting the output.
Rafa, what is the problem? Tell me.
So it's the same, but it's the same problem.
Okay. Okay, yeah, people who have got the output can leave the lab.
okay sir
Okay,
thank you
Rafa,
sir।
I'm making you the presenter. Show me. Share your screen. Yeah, Rafa, share your screen.
Yes, sir. So can we see it?
Yeah, I can see your screen. Show me the, yeah. Close it and zoom it. Little bit more. Please do the zoom. A little bit more.
Yes, sir.
Zoom it a little bit more. What is the output that you are getting, Rafa? You are getting nothing, or you are getting some other waveforms?
Sorry, sir. So I'm getting no output.
You are not getting any output. Okay. Can you please click on the voltages that you have selected? Click on that. It's 12. Okay. What is this voltages? Minus 12. Okay. Yeah, one more voltage will be there across the capacitor. You show me over there what you have connected across the compensation.
Yes, sir. 12.
That is 12 or minus 12?
So against the capacitor.
Yeah. Across the capacitor, that is minus 12. Minus 12.
Oh.
Now you try to run it after debugging. Yeah.
Still not sure.
Okay. Then there must be the problem with your hex file. Show me the key. Show me the key interface. You expand this target one. DAC.asm. This is from where did you get this file?
Which one?
This file. This is not the same program. This is some other program.
So I copy pasted the one that you shared.
Okay. So just a second. Let me check. Is this the same program? No.
No, so it's not. 1 second.
Let me check. No, it's not the same program. No.
Oh, so I think I've uploaded the wrong one.
Okay. Paste it over here. You copy it from there and paste it in the same window. Just clear this window and paste it on that. Control A. Paste it on this one.
So sorry.
No. You do it. Don't stop sharing. You copy it from the notepad that I have shared.
Yes, I'm.
Okay, and do it
So
on
this
the.
one, right?
It's already there. You have shown me, right?
Okay.
In your.
Okay, this one.
Copy it. Please copy it. I think you have selected some other program by mistake.
Yes, sir. I'll save it.
Wait. Let me see. Right, whether any. No. This is not the same program, right? I mean, whether I have shared any wrong file, then, or what? Let me
Oh,
check.
so I'm maybe okay. 1 second.
But
I'm
as far
actually taking it from the chat. Maybe you uploaded it.
take it from the chat, okay? But I think I have shared this. Okay, yeah. Go to the files. Go to files.
Yes,
Go to
sir.
files.
1 second.
ऊपर है माइक्रो कंट्रोलर एम्बेडेड. यहाँ पे दिख रहा है आपको सामने नीचे EMS ट्रैक. हाँ, गो टू यहाँ पे जाओ. ये कील फाइल्स. ओपन करो कील फाइल्स.
So this one.
हाँ. और you can select dac.txt as well. इसको जरा ओपन कर, डबल क्लिक करो dac.txt को. ये मैंने गलती से कोई नहीं, ये बराबर है फाइल.
Yes. Sir. Yes, it's the wrong file, I think, because I was doing ADC. I copy pasted from ADC.
Okay.
So I'll do that then.
Okay, do it. Yeah, anyone else has done this mistake in picking up the wrong file and generating the wrong hex file, then you will not be getting the output. I think
No,
everyone
sir.
has got it. Now only
But
2 or 3 people are. And
I have not got the
Ansh,
output. Yeah, sir.
what is the problem?
So it's the same that the oscillator is not showing any output.
Okay.
Yeah.
So you show me the screen in that case.
Yeah.
So
Rafa,
can
you
I
please.
leave the
Yeah.
meeting? I got the output.
Yeah, you have got the output, then you can leave. Jenica, definitely.
All right, sir. All right.
Okay.
Thank you, sir.
Ansh, please share your screen. Rafa, stop sharing your screen. Yeah.
Yes, sir.
Ansh, please share your screen. I have made you the presenter. Please share your screen.
Yes, sir. Can you see the screen?
It's loaded. It's loading. Okay, so when you run it, what is the thing that it is showing? Nothing?
Yeah, sir. It's not showing anything.
That means there is a problem with the hex file. Let me check it from there, first of all. You show me your keel interface.
So is it visible, the keel?
Have you put all the values over there in the crystal value? You have put 12 megahertz?
I've put 11.059.
Okay, that is okay. Okay, let me check a little bit. You please zoom it a little bit so that I can check it.
Yes.
Okay, that's it. Reference I out. Bus. एक मिनट. 26.1 this. ओके, यहाँ पे VCC भी. ये वोल्टेज कितना दिया है? C31 कितना दिया है, दिखाओ. C31 कितना?
सर इसको कितना देना है C3 को?
डबल क्लिक करो वहाँ पे. हाँ, -12 है ये, -12.
मैंने दिया ही नहीं था.
ओके, अभी रन करो. सेव करो, डिबग करने के बाद सेव करो और फिर रन करो.
Yes, sir. Now the output is coming. I didn't know that we had to give voltage to that also. Okay, sir.
Okay. Yeah, Rafa, you got the output?
Yes, sir. Just that it is going in the opposite direction.
Because to see the connection, okay, you please check your connection. I am telling you that you might have connected the ports to be in the opposite order, right? I have connected A8 to P1.0.
Okay, sir. I'll check.
If you have connected in the reverse order, then it will be coming in the reverse way only.
Yes, sir. But I got the output.
Okay, right. So later on, you please change
yes, I'm
the
doing
input.
it right now.
Okay.
Yes.
So shall I end the meeting now?
Yes, sir.
Yes.
Okay, fine.
Thank you, sir.
Yeah. Okay. Thank you very much.
Thank you.